Hello students, let's start with a simple thought. Why does sugar dissolve in water so easily, but only up to a certain limit? That very everyday observation leads us into the fascinating concept of saturated solutions. A solution is simply a uniform mixture of solute and solvent, for example, salt and water. But what really happens when you keep adding solute? Initially, the solvent particles surround and separate solute particles, making the mixture look perfectly clear. But soon, a stage comes when no more solute can dissolve. This is the idea of saturation. Keep in mind, this process is controlled by temperature, nature of solute, and solvent interactions. As you watch the slide, think of your cup of tea. Why do sugar crystals sometimes settle at the bottom even after stirring? That's saturation in action. Now, let's go deeper. An unsaturated solution is one where the solvent can still dissolve more solute under given conditions. Imagine adding a spoon of salt to warm water, it disappears instantly. That's unsaturated. But if you continue to add salt, there comes a moment when no matter how much you stir, the excess just sinks to the bottom. That's the saturated state. At this stage, the rate of solute dissolving equals the rate of solute particles crystallizing back. We call this a state of dynamic equilibrium because the two opposite processes happen at the same time but with no net change. So, when you see undissolved salt at the bottom of a beaker, it's not just lying there, it signals that equilibrium between dissolution and crystallization has been reached. Now let's talk about solubility and saturated solutions. Solubility is defined as the maximum amount of solute that can dissolve in 100 grams of solvent at a specific temperature. It is usually expressed in units of grams per 100 grams of solvent or in moles per liter. Solubility values vary for different solutes. For example, at 25 degrees Celsius, the solubility of sodium chloride is approximately 36 grams per 100 grams of water. The formula to calculate solubility is solubility in grams per 100 grams of solvent equals the mass of solute divided by the mass of solvent multiplied by 100. Solubility plays a crucial role in chemical industries. Fertilizers, pharmaceuticals, and even beverages are often prepared based on solubility data. Now let's look at the effect of temperature on saturated solutions. The general rule is that the solubility of most solids in water increases with temperature. A simple example is sugar. More sugar dissolves in hot tea than in cold tea. However, there are exceptions. Some salts, like potassium chloride or calcium sulfate, show very little increase or may even decrease in solubility when the temperature rises. This principle has practical applications too. Crystallization of salts from hot solutions is based on this temperature dependence of solubility. On the right, you can see a solubility curve which shows how solute mass increases with temperature. Next, let's understand dynamic equilibrium in saturated solutions. At saturation, the rate at which solute particles dissolve is exactly equal to the rate at which solute particles precipitate out. This balance is called dynamic equilibrium. The process is continuous but remains perfectly balanced. The equation is simple: rate of dissolution equals rate of precipitation. On a molecular level, solute particles are constantly leaving and entering the solution, but the overall concentration stays constant. A real-world example can be found in our oceans. They are in equilibrium with dissolved salts, and any excess salt eventually settles down as sediments. Now let's talk about supersaturated solutions. A supersaturated solution is one that contains more solute than its normal solubility at a given temperature. These solutions are unstable. The extra solute may crystallize out when the solution cools or even when it is slightly disturbed. For example, if you cool a hot saturated sugar solution, it can form a supersaturated solution. Supersaturated solutions are not just a lab concept. They are actually used in making rock candy and in crystal growth experiments. Let's now look at a numerical example of solubility in a saturated solution. The problem states 20 grams of potassium nitrate dissolves in 50 grams of water at 40 degrees Celsius. We are asked to find its solubility in grams per 100 grams of water. Step 1 is to use the formula solubility equals mass of solute divided by mass of solvent multiplied by 100. Step 2. Substitution 20 divided by 50 multiplied by 100 equals 40 grams per 100 grams of water. So, the solubility of potassium nitrate at 40 degrees Celsius is 40 grams per 100 grams of water. Such numerical problems are useful for comparing the solubilities of different solutes under given conditions. Let's quickly recap what we've learned about saturated solutions. A saturated solution contains the maximum amount of solute possible at a given temperature and pressure. We saw that solubility depends on factors like temperature, pressure, and the nature of both the solute and solvent. Saturated solutions also represent dynamic equilibrium, where dissolution and precipitation happen at the same rate. Supersaturated solutions, on the other hand, are unstable and crystallize easily. We also discussed important applications in medicine, food science, crystallization, and industrial solution preparation. So now, you should be able to clearly explain how saturation defines solubility and why industries rely on this concept every day. See you in the next topic.